So I'd like to talk about distribution of data and some patterns you might see when you look at frequency distributions. Now, typically we can describe it in one of four ways. The first way is a U-shaped distribution. So a U-shaped distribution occurs when there are peaks at either end of the range. It may also be described as bimodal. And so if we take a look at the scores of a game of Spider Solitaire, now you get on the low end, you have a larger frequency of certain scores in the range of 400 to 449. Then as you move up these classes up to 800 to 849, you'll notice that the frequency begins to drop, hits zero at the middle range here, and then starts to increase again. So when you graph this, you get a U-shaped distribution. And what we mean by bimodal is there's a mode here and also a mode here. So in this case, this would be a U-shaped distribution where we have at the ends of, at the low end and at the high end, we have peak frequencies. Now, uniform distribution, we've seen this previously, and that's where the height of each bar is roughly equal. And if you rolled one die, you might get something along the lines of this if it's a single die and it's fair. So when you graph this, you more or less get a uniform distribution of each possible outcome when you roll a single die. And so this is called a uniform distribution. There is really no mode. There is really, the mean really doesn't tell you much because the mean is going to be somewhere around 3 or 4 if you add all this up. And so this really doesn't have as much meaning when you talk about a mean or mode. Now, Moundshaped distributions, this is where the middle interval has the greatest frequency. And it takes on a mound-shaped distribution, or it looks almost like a hill. And we'll look at later on at what's called the normal curve, and we'll see that that is a mound-shaped distribution as well. Now, if you roll 2 dice in this case, well, then you expect the frequency of a 2 to be very low as well as a 12. And then as you move closer to 7, the frequencies will increase. And then when you move greater than 7, the frequencies will start to decrease. And so if you graph dice sums, and we saw this previously, that you're going to have a mound-shaped distribution here where the frequencies are lower at each end of the range, since our range is from 2 to 12 for dice sums. And so then our mean, median, and mode will be somewhere around the middle here. Skewed distributions. Now, in a skewed distributions, the one end of the range has a greater frequency than the other end of the range, and it seems to tail to the left or to the right. And so if we take a look at the data here, we see that in a game of solitaire, a score of 0 to 19 is very frequent. And then as you move up through these classes, you see that the frequencies start to drop. And so if you graph this, it appears in this, to take this form, and we say that this is skewed to the right, which means that it looks like the data has been pulled to the right side. And so here this would represent data that's been skewed to the left. And again, think of it as the data is being pulled to the left side then.